Good afternoon, everyone. Today, we are here to present our innovative idea for a tech venture. I am Yo-Yo, and they are my teammates, Chester and Daniel. In this decade, ever since the launch of smartphones, various types of gadgets emerged and become an indispensable part of our everyday life. Tablets, smartphones, laptops, I believe must have tried using at least one of them. Due to technological advancement, paper and pen have gradually been replaced by these gadgets and digital pens. Users can access and annotate their notes at any time and anywhere with a single portable gadget. However, there are still some limitations that exist in these conventional portable devices. For example, tablets. They are brittle and are often big in size. As a general public, that might not be a big problem. But when we try to apply this technology into some specific fields, this would be a big obstacle, as it is very inconvenient for some occupations to carry the tablet around on field. And this is how we got the idea to replace tablets with with writing glass, a wearable device that allows users to access and annotate digital notes with their hands free. So I'll pass the time to Chester to talk about our literature review.
Thank you, Yo-Yo, for the introduction. The existing technologies give us enlightenment on how our innovations brings convenience to users. The writing glass is inspired by augmented reality glass from Google, the prototype of our invention. The augmented reality, AR, is a technology that overlays the virtual elements into the real world, like images and digital documents. The Google Glass mainly comprises AR technologies and camera for streaming the virtual elements on the lens, and also some minor components like mono speaker, USB audio for providing multiple audio options, and also the dual band Wi-Fi for documents downloading in connection to Android operating system. Yes, all these can contextualize virtual elements for users, and as highlighted by Google, it is an excellent addition to the business workflow. But as you might notice, it lacks interacting features. The virtual elements are just visualized on the lens, and the users cannot make changes on them. So for this reason, the potential functionality of Google Glass is greatly limited due to the absence of the interactive features. Another existing technology is the Apple Pencil of iPad. It is always the first priority when it comes to choosing a learning tool at university, and it is not without a reason. It changes the manner of writing fundamentally and innovatively through introducing a way of handwriting that is 100% paper-free. However, there is still one considerable shortcoming of the Apple Pencil. That is, only the user's personal iPad can interact with it. The pen-enabled surface of the iPad is tailor-made to collect data for functioning users' personal Apple Pencil, including the pen tracking, force measurement, and the orientation measurement. What makes it incompatible with other smart devices is that a personal Apple Pencil can only recognize one iPad. It means that others' iPad or tablets without the pen-enabled surface are unable to work with it. Imagine today, the only learning tool you have in hand for the lectures is an Apple Pencil. Without your own iPad, it becomes useless. As a result, the compatibility problem gives us insight on our innovation. Here are the technologies applied to the writing glass for dealing with the above problems. The in-house VX1 technology by Watson is a 3D volumetric projection that can visualize a physical cross-sectional image at precisely the right place on a plane surface. And for the LiDAR, the navigation or the motion sensor releases and detects a beam of laser light to collect and deliver the motion information, specifically the gesture of users for interacting with the writing glass, and also collect the position information that produces a 3D image of a physical object. Besides, the writing glass adopts anchoring function of the camera. It acts as a stabilizer to compensate for the head movement from 5 different axes. So how exactly these technologies work together? Let's have Daniel to explain the technical details.
Thank you, Chester, for the literal review on the intelligent glasses. In the following, I will introduce the technical details of our invention called writing glasses. The writing glasses could project a 3D writing interface on a writing desk. The writer could use a digital pen to write anything they want on such virtual writing interface. Okay, let's have an overview of the writing glasses layout. The glasses are consist in 5 parts. They are LiDAR sensor, the 3D projector, the digital pen, and the central processing unit, the CPU, and of course, the battery. The LiDAR is allocated in front of the glasses. It is responsible for 3D scanning and detecting the movement of the digital pen. The 3D projector is responsible for displaying the writing interface with billions of light rays. Besides, there is a built-in stabilizer inside a 3D projector to compensate for the head shake, which will disturb the user from writing. Next, a digital pen is hung on the side of the glass frame. Finally, the CPU and the battery is installed on another side of the glass frame. That's the layout of the writing glasses. Next, let's take a look at how these 5 components work together. Let's imagine this scenario. The user wearing the writing glasses goes into the study room. Firstly, the LiDAR sensor will perform a 3D scanning of the surrounding environment. Then, the CPU will generate a 3D map of the study room according to the scanning result of the LiDAR and recognize the writing desk, the physical writing desk in the study room. After locating the position of the writing desk, the CPU will instruct the 3D projector to display a virtual writing interface on the writing desk. After all, the user could write some words on the virtual writing interface with the digital pen. The LiDAR sensor will track the pen's movement, and send the data detected by the LiDAR to the CPU. The CPU will recognize what the users wrote about and tell the projector to display the corresponding words, such that the user could observe what they just wrote about, and according to the projector's image, such that the user could observe what they just wrote about according to the projected image. Okay, and of course, our head will slightly shake when we are writing. Then the projector will shake, follow our heads, and also the projected writing interface will move around on the writing desk. This is undesirable and make our user impossible to write anything on it. So the built-in stabilizer inside the projector could solve this problem. The built-in stabilizer will counter the head shake by moving the projector up and down, left and right, such that the stabilizer could anchor the virtual writing interface on the writing desk without moving around. Then the user could have the same experience as they write something on an ordinary paper. That's the technical description of the intelligent glasses, the writing glass. I will hand over the time to Yo-Yo to introduce the feasibility of the writing glass.
Thank you, Daniel. After explaining the technical details of our innovation, I will now move on to its feasibility and benefits. They can basically be divided into 5 aspects: convenient, efficiency, interactive, environmentally friendly, and cost. So let's start with convenient. The writing glass is convenient for users as it allows users to access and edit the documents anytime and anywhere with their hands free. That might not make much difference for general public, but particularly useful for application in occupations such as engineering and logistic industries, which involves a lot of field work during their work. With the writing glass, they can make notes and annotations on-site easily without carrying a heavy tablet or a piles of paper. This will bring us to the second aspect, efficiency. As they can easily annotate their notes during on-site, it can definitely boost their work efficiency. Besides, they will also be able to share their snapshots and annotations on-site immediately with their colleagues. And so they can immediately start discussing on how to proceed their work or how to tackle the problems they discovered on-site. And this could highly boost their work efficiency as they could start work faster and can help them communicate more efficiently. So the third benefit of our innovation was the additional interactive feature. Most of the similar existing innovations in nowadays, such as the Google Glass, only offer users to view the 3D image or do some simple voice command. But for our writing glass, by implementing the LiDAR technology into the glass, we allow users to give command through their motion. As the motion sensing feature provide users an extra way to interact with the device. The writing glass could detect the user's motion, in particular their handwritings, and record them, and then later would deliver and display their writings through the projectors installed on the glass. This can make the device more handy for the users. Furthermore, our writing glass is also very environmentally friendly. While conventional tablets can help us go paperless, our writing glass is going one step further. It is apparent that the tablets are larger in size and would involve more electronic components compared with the writing glass. So during the manufacturing process and the disposal of hardware, the tablets is likely to produce more electronic waste. So by replacing the tablets with our writing glass, we could reduce the waste generated during the manufacturing and also the disposal of such electronic hardware. We could also further minimize the use of paper because the writing glass can be applied in more different specific industries. So after talking about so many benefits and knowing about the technological details of our design, you might think that such a sophisticated design must be really costly. But in fact, the technology we've just mentioned in our innovation, such as the 3D projectors and LiDAR technologies, are becoming more and more widely used in our everyday life. For example, the LiDAR sensors are actually applied in many smartphones, which serve for the facial recognition function. So actually, if these technologies get more matured and more widely used, the mass production of our writing glass could significantly lower its cost. And so maybe in the near future, the cost of producing a pair of writing glasses might cost no more than the cost of manufacturing a smartphone. So it is likely to be affordable for many general public and also companies. So now I'll pass the time to Chester to summarize our presentation.
Thank you, Yo-Yo. So let's sum up our innovation. Our writing glass aims to simplify the way of writing. There is still room for improvement, especially for the limitations and deficiencies that we mentioned. Before its implementation, we hope that further investigation can help perfect our writing glass that can bring a new page to the manual of writing. Thank you.